Stop. All right, so what is the inverse of an exponent? What's the logarithm, right? The opposite of a logarithm is an exponent. So, let's see. Let me find the right color. All right, so with this equation, we have the variable that is in the exponent, so then we want to undo that exponent. So we're going to take the logarithm of each side. What is the base of this exponent? What's the base number? 8. So that means we're going to take log base 8 of each side. Hey. What? What did you say? All right, so if we take the log base 8 of each side, then what ends up happening? There's something that we can cross out because it equals 1. Log base 8 of 8 equals 1, so we cross that out, and so then we'll have 6a equals the log base 8 of 53. And then what's the last step to solve for a? Yep, divide by 6. So make sure when you plug that in your calculator, you don't put the divide by 6 in the parentheses. It has to go after the parentheses, okay? So the log button is where? Control 10 to the x is where the logarithm is. So log base 8, 53, and then go outside of the parentheses, divide by 6. All right? 0.31. All right, so once we have the term that has the exponent alone, then we did the log of each side, right? Okay, so let's do this one. Has a few more steps. I have some in my first aid kit. Okay. Yeah, right. Okay, so first we want to get the pink around it means it's infected. I guarantee you. We got to amputate the arm. Yep, we do. Okay, we want to get this term alone. So what do we want to do first? Thank you. So we minus 8 to each side. And then we go negative 10 to the 8 minus 7k equals negative 85. Oh, come on. So if they're both all right, so we have a negative number equals a negative number. So what do you think we can do if they're both negative? Divide by a negative 1, and then it will just make them both positive, right? If we multiplied by negative 1 or if we divided by negative 1. Okay, now we can undo the exponent by taking the log of base what? 10. So we go log base 10 on this side of the equation and log base 10 on this side. And then what ends up happening when we take log base 10? Yep, so log base 10 of 10 is 1. So then we have 8 minus 7k equals log base 10 of 85. Wait, no, sorry. And then what would we do next to solve for k? minus the 8. So we minus the 8. Notice when I subtract the 8, it's not part of the logarithm. It goes after the logarithm, okay? That's why I only wrote the 85 in the parentheses. And then we'll have negative 7k equals the log base 10 of 85 minus the 8. So the last step is to do what? Yep, divide both sides by negative 7. So what I would advise is just do the fraction button and then just enter it in exactexactly how we have it written there. So .86. Wait, was it minus 7 or minus 8? Divide by negative 7, right? All right. You need to do the fraction button first. So control divide first, or you would need to enter the parentheses, okay? Anyway, so k equals 0.86, right? All right, so any questions so far on logarithms or exponents? Or, sorry, just logarithms. Okay, let's write down this next equation. So when we were first learning about logarithms, like when I first introduced you to the, like what a logarithm is, I wrote this problem. I wrote 2 to the third equals 8. And then I wrote that same problem written as a logarithm. So that would be log base 2 of a equals 3. Because the answer to a logarithm is the power, or the exponent. So then you read it as this to this power equals this number. Okay? So it's read as this. So 2 to the third power equals the 8. That's how it's, okay? So it's kind of like a circle like that. So if you know what a logarithm is and you know how to read it, then this, and then an equation like this is easy because it's just 9 to the third power don't do that, equals x. So 9 to the third power equals x, right? And that's 729, I think. 729, I think is what it is. All right. Or what is it, 30? Like, was I wrong all day with this problem? What you could also do, and this is how we learned how to solve, is since the inverse of a log is an exponent, then we exponentiated the equation. So we did a 9 here and a 9 here, and then we crossed that out. So then it was 9 to the third, which is 729. Okay? So let's do that on this one. Sorry, there's a lot of examples today. Yeah. What did you say? All right, so what we want to do is we want to get the logarithm by itself. So what should we do to get rid of the negative 8? So do we add it or divide? Yeah, because it's multiplying, right? So we want to divide by negative 8 since that's the inverse of multiplying. Okay, so when we divide by negative 8, then we have log base 11 of v equals what? Positive 2. So we could solve this one of two ways. We could exponentiate the equation with an 11. So 11 down here, 11 down there, right? Sorry, that's one way. Or if you know what a logarithm is, let me undo that. Brian, you guys. If you know what a logarithm is, you can go 11 to this power equals v. Oh, why did you do that? So 11 squared equals v, right? So what's 11 squared? 121. All right. Okay, so questions on logarithms then. Question. You're good? All right, now let's draw this right triangle. Let's review. Oh my gosh, stop doing that. Sorry, you will probably have 2 pages of notes today, which is fine. Oh my God. Hold on, this is number 5, right? Okay, here we go. Draw that triangle. All right, so since this is a right triangle, to find angle A, then we can use SOHCAHTOA, right? What is the 10 in relation to angle A? Is that opposite, adjacent, or hypotenuse? Opposite of angle A. What's the 9? Adjacent to angle A, right? So which one in SOHCAHTOA has O and A? TOA, which is tangent, right? So we're going to go tangent. And now, since we're finding the measure of an angle, Brigham and Ryan, please listen. Since we're finding the measure of an angle, then we want to do the inverse, or the arctan, the -1. Okay? So tan of the -1, and what's my fraction? 9 over 10 or 10 over 9? 10 over 9, because it has to be opposite over, why does it do that? Over adjacent, okay? So remember, it's the trig button. What? All right, did you guys get 48 degrees? Okay. So questions on that one? All right, let's do one where we're finding a side length. So let's do this. All right. Do we have this?
We got 4.
All right, so what is the 9 in relation to angle B? What's the 9? No, hypotenuse, because it's opposite the right angle, right? So what is the x? Opposite or adjacent to angle B? Adjacent. So which one in SOHCAHTOA has A and H? Ka, which is cosine. So we're going to go cosine of what?
Cosine
of our angle, which is 57, equals what? Sorry. Something over, so what's our fraction? X over 9. So then what are we going to plug into the calculator? Because we need to solve for x. We're going to times by 9 to each side. Right? So that's what you're going to plug in. It's just 9. We learned this when we reviewed SOHCAHTOA. It's 9 times cosine of what? Was it 57? Okay. Bless you. So 4.9. And you know if you got a number that was greater than 9 that you probably did something wrong because 9's the hypotenuse, right? So that's the longest side. Now, could you use law of sines to find that side? Yep. So law of sines you can use for a right triangle or a non-right. But SOHCAHTOA you can only use it for a right triangle. Okay? What? I know it's not to scale. Most likely the picture isn't. Okay, this is, oh wait, that was, no, that was 6. This is number 7. Okay.
That is 8, guys.
No, I deleted 7, so this is really 7 now.
It says 8.
I deleted 7. Calm down.
Answer's 8.
Funny. So what is another name for AC? Is that side A, side B, or side C? I know.
What?
Yeah, because this would be side B, right?
Oh.
So is this a right triangle? No. So that means we have to use either law of sines or law of cosines. Do we have an angle and its opposite side length?
Yes. No.
No, we do not. So that means, so we have side angle side, right? This side angle, this side. So that means we can use law of cosines and it will find side B. So do you remember the law of now, the good news is you won't have to memorize this for the final. I'll write it up here on the board. So the formula, remember, is the square root of, is this long one? 12 squared.
Oh yeah, this one sucks.
Plus
21.
21 squared. I can't remember. 2 times 12 times 21 times, do you remember the last part?
Oh, cosine of 104.
Yep, cosine of the angle. All right, plug that in. Let's see if we get the same thing as your neighbor. Did you guys plug it in? All right, what did you guys get? So 26.5. Oh, why did I said 26 and I wrote 25. Oh my gosh. Okay, 0.6 centimeters.
Wait,
all right.
When you have a side.
So side is where you use law of cosines, but then you're solving for the angle. So that's where we squared each side of the equation. I'll walk you through one of those. Okay. I think on your assignment, no, on the assignment. Okay, let's do this one. This is number 9, right? Or 8? 8? Thanks. Okay, I think this is the last one that I'm going to do. Yep, this is the last one in your notes. So. help you. All right, so this one, it's not a right triangle, right? So do we have an angle and its opposite side length?
Yep.
Yes, we have angle C and side C, right? So law of sines says that we can go sine of angle C, which is 76, over side C. I hope you're all listening. Thank you. So side C is what? 26. And then what are we solving for?
B.
No, are we
BC.
side BC or side A? So that means we need to use angle A, right? So then we're going to go sine of angle A is 45 over A. Then what do we multiply? Yep, so we go 26 times this divided by sine 76 in the calculator, okay?
Sine of 45 times 26. Wait, how do you get to this?
What?
Oh, let's go. Let's do one more. How do you get to the sine first?
Trig.
Trig.
Mm-hmm.
What?
Divided by sine of what? What's the other one? So 18.95, is that what you guys got? Okay, perfect.
No.
All right, so any questions on the law of sines or cosines? All right, so the assignment that you have in front of you, we're working on the rest of the class today and tomorrow, if you're here. If you won't be here, you know what we're doing. Yeah, it's a full day tomorrow. No, the next Friday is an A-day. May 3rd is an A-day. Yeah. Okay, let's do what? Okay, let's look at number 7. Once you guys have your name written. All right, now in our notes, we didn't have an equation like number 7. That's why I wanted to look at number 7 with you. Do you guys remember when we have a logarithm equal to a logarithm, what we can do to solve it? Yep, we can just cross them out. So we can cross out the logarithms and we'll have negative 15x minus 3 equals x squared plus 47. So now we have a quadratic equation. So what should we do to solve that? Set it equal to 0. So since this term x squared is positive, then I think it would be easiest to move these terms to the right side, okay? So add 15x and add 3. So 0 equals x squared. And we have how many x's? Yep, plus 15x, and then 47 and 3 is 50. And then now we want to find factors of what number? 50 that add up to 15. So then, what are they? 5 and 10. And are we finished there? So if those are the factors, the solutions are the opposite signs. So it'll be, law, what'd you say? Negative 10 and negative 5. Because they're the opposite signs of the factors, okay? All right, and the answers are on the back for you to check as you go along, okay?